Hello, welcome everybody to today's webcast, Cloud Economics, Getting Maximum Return on Investment. My name is Ben Dunmire. I'm a Business Intelligence and Analytics Consultant at Thorogood, and I'm speaking to you today from the U.S. in Philadelphia. A brief look at an agenda for today. So I'll briefly introduce Thorogood, talk about what we do. Then I'll get into the core content, talk about a few fundamental concepts and things that a lot of people are pretty familiar with, but we'll want to make a few points. Then we'll get into what we're thinking about with cloud economics and responsible cloud usage when it comes to data and analytics workloads, and then transitioning into why does that matter, what's the value, what are some of the risks that are posed, and then wrap up with a few parting thoughts and areas where we really see a lot of focus now. So for those of you who don't know Thorogood, we're an independent global professional services firm specializing in business intelligence and analytics strategies, solutions and services with a focus on our customers. We're a global company, so we have offices in Philadelphia, Boston, London, Bangalore, Singapore, and Sao Paulo, Brazil. All our consultants are recruited and trained in the same way to develop a unique mix of skills, blending business understanding in the form of industry and functional experience with strong technical aptitude and a deep understanding of analytical tools and practices. We do offer a full range of BI analytics services, including strategy and roadmaps, requirements design, implementation, and training and support. In terms of the technologies we work with, we are an independent firm, meaning we don't work with one specific technology vendor. We do, however, work and partner with many of the key players in the market in order to provide our clients with the solution that best suits their needs. And when we're thinking about the cloud, nearly all, if not all of these technologies, have some key considerations or connections. So, Microsoft Azure and AWS probably jump to the front of your mind as leaders, as vendors providing full cloud ecosystems. We can also think of Databricks as a data engineering and data science tool, Anaplan, Salesforce, software as a service offerings, and certainly the others here. So working with numerous technologies in the industry, it allows us to use the appropriate tools to best effect, depending on the situation and need. So let's get into it. We'll talk a bit about some kind of just fundamentals of cloud and some fundamentals of thinking about the economics of cloud. So here we see all the different cloud services models on the right of the screen, and then on the left is the traditional or on-premise model. So we think about the leftmost, the on-premise model first. This is packaged software. You're doing everything from application design, operating system, networking, and it's either you or your IT department's responsibility. In the cloud, we have kind of different options, different models, which present opportunities and of course, new challenges. So the first lowest level of utilization is infrastructure as a service, or IaaS. Here, as there are things like the operating system and configuring virtual machines, while things like the server, storage, networking are all handled by the cloud vendor. So this is often the basis for a hosted solution, so something like RStudio, for example, as well as data centers and core infrastructure. The next level, platform as a service, and this is generally where, with data analytics, where we do a lot of our work. You're no longer responsible for things like the operating system and runtime, and really just focus on the data and applications themselves. So how are you configuring the software to ETL or create visualizations or run data science models, those sorts of things. And everything is, again, running on the vendors, so AWS, Microsoft, Google's compute, and you have the ability to configure the application layer. And lastly here, software as a service. So maybe one we're most familiar with because of all the front-end tools, Salesforce, for example. And this is the really lowest level of management, I would say, from a pure infrastructure perspective. Everything is being managed by the vendor, and all you're really doing is managing subscriptions, configuration settings, those sorts of things. And what's kind of useful to think about, and a traditional way to think about it is you're effectively in on-premise, you're getting rid of or no longer having to pay for CapEx, capital expenditure, and certain labor costs, and moving to a more of a pay-as-you-consume or on-demand model. And there's still, of course, support needs. There's different operational needs, so it's not a perfect swap. But that's a kind of traditional way to think about it, replacing CapEx with OpEx. So what's the point? Why are we talking about the cloud? Why is everybody talking about the cloud? Scalability, so scaling out, meaning adding more compute for more distribution. Scaling up, so making things larger with relative ease or efficiency. Elasticity, so a very similar concept, but the idea of compute scaling automatically, not needing to have to go in and then someone plug in different devices in an on-prem data center, but the ability to scale on demand, flexibility. So they're really pretty broad, but the ability to create things quickly, to spin up infrastructure in a matter of seconds, to change sizing, to do deployments very, very quickly. So this sorts of massive gains in speed and efficiency. And responsiveness. So I think one of the key points we often talk about is responsiveness, agility, the ability to respond to new needs, new demands, new challenges very quickly and with rigor. And then different options. So, a lot of new, maybe not new now, but, modern technologies, modern tools, cloud-based or, rely heavily on the cloud. So really opening up the possibilities of the modern tools to use them. So again, something we're probably quite familiar with, but setting the groundwork here a bit. We're talking a bit more about economics and this economics 101 here, but there's a few things to mention to be thinking about and touch on some of them later in the presentation. So we're just defining here. So economies of scale, and not necessarily just a cloud concept, but the general economic principle, but the idea that as you increase or add more scale to something, you recognize cost benefits or cost advantages. So the idea of AWS, Microsoft, Google buying massive amounts of hardware, big data center warehouses in different locations around the world at pennies on the dollar, presumably, compared to singular organizations purchasing their own. Those cost savings should trickle down to consumers. That's a key concept. Global reach. So the idea of cloud vendors and cloud computing being everywhere accessible across the globe, and the ability to quickly move from place to place, whether it's data or systems, with relative ease. The total cost of ownership. So really, this is the way in which we'll try to quantify any type of purchase, really, but the idea of quantifying and weighing the cost and benefits of a cloud migration or a cloud purchase and trying to come to a purchase price. And it's beyond just currency or payments, but thinking about what new functionality or new benefits might you get from making some investment. And it's important for the cloud because from a pure dollars to dollars perspective, it might be the same. Cloud might be more expensive, but what are you getting? Agility? Are you getting new tool, access to new tools, those sorts of things. Cost of migration. So again, maybe obvious, but the amount of time, effort spend towards migrating workloads to the cloud, and also thinking about parallelization. So presumably you have to have something running until you're fully ready to flip the switch. A few instant concepts. I'll go through these pretty quickly because this gets a bit more into VM hardware as opposed to some data analytics stuff, but certainly useful to understand from perspective like tools like Databricks or RStudio. On-demand pay-as-you-go is maybe most common, but the idea of paying as you use something with no necessarily long-term commitments, and it's usually hourly or daily in some cases. Reserved is the idea if you have an expected usage for a long period of time and you're able to commit for 1 year, or 3 years, or 5 years to pay for something. So can be thought of as a sunk cost, but you're presumably getting cost savings because you're willing to take something at a discount because you're committing to it for however long. So spot to and not that relevant or common of a concept, but with these cloud vendors, they do have extra capacity at all times. They have to have the ability to scale as well. So they will sell any of their extra compute in different regions, kind of as they're available, so hour by hour. So there's no assurances those will always be there, but these are particularly relevant. They're the cheapest option because they're not guaranteed and they're not committed to. But if usually a backup plan for massive spikes or major urgent issues where you just need to quickly get your hands on something. A dedicated host, which I don't think is as common as it initially was with the cloud, but the idea of having physical servers in the cloud computing center or physical machinery, just dedicated to one person, but one customer that is. So a few concepts here. We'll set the stage a little bit, but I think we'll get kind of more into some of the key focus areas and what it means for us and how we can take advantage of. And that's what we'll get into next. We talked a bit about some of the benefits, and I'll run through, I think, some of the key ones here. So what is the cloud allowing us to do or helping us achieve that we might have not done before, or improving strengths? So agility and responsiveness. I mentioned this a couple of times, but that idea of being able to spin up resources in a matter of seconds to be able to get started on what might have taken 3 months or 4 months to get provisioned in the past takes 3 or 4 minutes. So those sorts of things, and just the ability to take on new challenges and questions quickly. And operational resiliency, so might lend itself more to think about data centers and things, but the ability if there are issues, there are problems, to respond quickly to them and have that resiliency of backups and sort of the things. More of a soft benefit, but the idea of promoting innovation, and not necessarily that the cloud is innovative, but it's on the leading edge and technology is moving in that direction, and also the idea of attracting top talent, top engineers and data scientists and experimentation. So a big thing we've been talking about right now, particularly during the pandemic, is the ability to quickly iterate and try different things. So our forecasts are totally different. They might be irrelevant. We need to know what's happening very quickly in our market, in our industry. So the idea to be able to experiment, to try different tools or to try different processes without the investment of setting up a whole process just to see if it works or not. You can try something one day, it doesn't work, turn it off and throw it away. Allowing IT to focus on maybe R&D or other activities, technical debt. This goes with experimentation, but kind of enabling that failing fast mentality. So we don't have to have a full waterfall approach plan that we need to have all lined up. We can give something a try multiple things and get it right as we go along. DevOps, so I'll come back to DevOps a couple of times, but not that DevOps isn't possible with on-premise, and it certainly is, and it is certainly used, but it is much becoming very, very relevant, and there's kind of more tools, more offerings with the cloud, particularly around infrastructure management, but also things like automated testing and the ability to scale with demand. So who knows how volumes might increase or never executions might increase, the ability to scale as needed. Some of the benefits, what are some things to keep in mind, to watch out for? And these, it might be like hidden costs or hidden challenges, things similar to that, but really what some areas where we see people getting into trouble or not necessarily planning out fully. The effort and time to refactor and rework things. So if I'm moving from a data solution, an end-to-end solution from one set of technology to another, it's not just a copy and paste. It's rebuilding. It might be rethinking it. Right? We have the data lakehouse paradigm. We're probably reworking a lot of things. So that's going to take time. That's going to take expertise. That's factored into any cloud investment. The retirement and decommissioning costs. So if you have a system, and generally I think this would be pretty straightforward, but will be some costs incurred with deallocating resources or archiving data, whatever it might be, with getting rid of an old system and switching it to the cloud. Reskilling, so a big one. Generally, a lot of technical concepts translate, but with maybe different tools in the cloud, different like infrastructure guidelines or approaches, it's very important to be able to have a good sense of that, and to also be applying the right skills to build things to high quality. Coming on to new operational costs. So one of the first slides we talked about replacing capital expenditure and labor costs with operational OpEx and just pay as you go. But you might have new operational costs of things like cost monitoring or having your finance function set up to handle that, and certainly others we could probably think of. But what are those new operational costs that I now have to pay for cloud? Having parallel support models. So if I have something, if I'm in the process of migrating to the cloud, I'm probably running two things at once. I might have some overlap, just as a disaster recovery sort of plan. So you might have that to contend with. Cost of migration. So I mentioned this, and this probably falls into the box to the right. But what does it cost to actually do the migration? Skill, time. Something interesting, but we've seen it take time to perfect cost of management. So to get your tags right, to have that joined up between how the business operates, how IT wants to operate, and how finance wants to operate, and also to have people on board with it, understanding it, using it correctly. So that can kind of hurt you because you might not get insight and visibility early and right away. And then maybe depending on industry, but with things like GDPR, CCPA, maybe not initially thinking about data privacy design. I think a lot of times we're thinking about that, but that adds in complexity, whether it's additional security features or costs that you have to pay to achieve some computer standards or principles. Hopefully that helps to think about what are the benefits, what are some things to be aware of. Here I'll talk about really where we're seeing for data analytics, a lot of initiatives, a lot of investments to kind of get a sense of where organizations are going. A big one is migrating from infrastructure as service or on-prem. We can think about them maybe congruently to platform as a service. So, taking something from an on-premise SQL server to Azure SQL or RDS. And that's kind of taking advantage of new functionality, but also not having to pay for it and look after those VMs or servers that are hosting the solution. I mentioned data lake house, but the modern data platform, we're seeing, I won't say all organizations, but many people rolling out their solutions and investing in them and looking to drive adoption. And really, you want to start with getting the data into that platform, but seeing how analytics fit in, how self-serve fit in, really interesting. And I think we're seeing a lot of focus. I mentioned experimentation, but that's the idea of having that on-demand compute for data science, then data engineering to quickly look at a new data set or evaluate a new model or something like that. So being able to do that very quickly, effortlessly, and without much lead time is really helpful. DevOps, as mentioned already, but automation, productionalizing, infrastructure management. We're seeing a focus on investing in DevOps skills and in defining a DevOps strategy. Number of places, most of a tangible thing, but just reducing lead times and adding to that value add and making us quicker to respond. And then I doubt a lot of places are right away cloud on-prem to cloud. There's going to be a lot of hybrid data architectures and presumably for a long time. Our big ERP and ECC systems likely going to remain on premises or on infrastructure as a service. So we also have lots of, I imagine, models, reporting applications, data warehouses. How do you get maximum value out of those existing investments? We don't necessarily want to blow them away if we can, or rebuild them even. So how does that hybrid data architecture and strategy look? I think we're seeing a lot of focus there, particularly as people are rolling out their data lakes, just thinking, how does my data lake fit alongside my existing warehouses that have served our business for 15 years? So here's really, I think we're seeing a lot of focus at the moment. So getting into why should we care about this? And ultimately, I think a big piece of it is driving a culture of responsible cloud usage. So to get the most out of cloud, to get that return on investment, it's about being conscious of how you're using the cloud, how you're designing solutions, how you're engineering things. And really, if we're thinking about the cloud economics, like how do you get the most bang for your buck? How do you get economic advantages over your competitors? It's about being responsible and thoughtful with how you use the cloud for your solutions. And something else to think about is there kind of being able to remove barriers. So we won't want kind of poor usage of cloud to be a detriment to business sponsorship or people going to applications. If we say, well, we're really nervous about our cloud costs, we don't know how to control them, people might be a bit nervous to say, to go ahead with a new innovative project or something like that. Quality is a big one. I think if you write a piece of code that takes 10 hours to run and then somebody else writes it to take 10 minutes to run, you're suddenly recognizing cost benefits in the higher quality, the better written code. It's a very simple example. But having certain governance strategies, thinking about quality is a really good way to achieve responsible cloud usage because the better the solution, the more thoughtful it is, likely going to be most cost effective. And that's what we found kind of coming in and assessing solutions and giving recommendations and then implementing revisions to existing cloud solutions to make them more cost effective and higher quality. So driving a culture, and really think about a DevOps culture, agile culture, but the idea of collaboration, having a cost management mindset, having kind of shared responsibilities is a big one. So balance between cost, performance, time it takes to deliver something. So not a perfect scale there, but you don't necessarily want to pick the largest, strongest compute you can because you think it'll be fastest, it'll be most expensive. So there's not some perfect formula or golden rule that we can follow to calculate that in most cases. I think it's I think a bit of intuition, a bit of testing, evaluation, collaboration to get that balance right. And that's drives the responsible usage. Right? We have some demands, but we also want to be conscious of costs. And attracting talent. So, thinking about developing talented people in your organization that are cost engineers, data engineers, data scientists, all thinking about the costing of things and how do you have forward-thinking data analytic teams. Talk about a few places where those issues arise with that responsible cloud usage. So development environments, we find that leaving development environments running when a solution's already been productionized, or having multiple versions because you have or backups or whatever it is, having development environments 10 times the cost of production environments. And you do expect to extend development environments where you're doing more work, you're being more active to be more expensive, but you got to be very, very mindful of it. And often people are focused on production as opposed to development. And then kind of that same vein, leaving things running when they're unused, no longer needed. I think the continuous improvements is an important one with the cloud, and focusing on where do you have technical debt, where do you want to improve your mechanisms, your alerting, whatever it might be, and also we see kind of a lack of automation being a threat to that. Not having a clear tagging strategy, so it kind of just creates confusion and a lack of collaboration, which probably also lends itself to limited visibility. So if I don't know what my solution is costing, what parts are most cost prohibitive, how can I really adjust it? How can I make logical changes? We've also seen as people adopt the cloud, push for the cloud, a slower focus on cost. So not thinking about that first thing about we have to get to the cloud, and this I think really reasonable and expected. We wanted to get to the cloud, but pretty quickly after, we want to make sure we're thinking about cost management. And sometimes having a difficulty estimating cost because there's so many factors and maybe some things that are hidden. So some things to keep in mind, particularly for data analytics solutions, data movement being very intentional. When we're moving out of the cloud, so egress is going to be more expensive than ingress into the cloud. And always we want to think about where is the source of our data, what's the destination, where are the users, and where's the compute. We want that to be as close as possible, and having less cross ocean transit or something like that. Thinking about storage. Storage is very cheap. It's unbelievably cheap. There are tiering to it, so we can even recognize some benefits in the tiers, but take advantage of that cheap storage. I won't use storage as a key focus. So if we're thinking about compute, that's where the cost is really incurred. So data engineering, data science workloads that are really intensive. Thinking about sizing infrastructure well, having good collaboration and people using shared infrastructure where appropriate, turning things off or using serverless when you can. And then relational storage, whether that's models like analysis services or database technology. It's important to understand how those are costed. So in most cases, there's a blank, a singular cost. It's not based on usage. This is the storage. This is the level of responsiveness compute you're paying for, no matter who's using it. So understand the resource you're using, how that's costed, but do things like scaling up and scaling down, turning it off and on. So I'll wrap up here with just a few points on driving action. So get the fundamentals right, education, policies, tagging. Next phase, thinking about alerts and notifications. So how do we drive change? How do we put some automation into turning things off when they're unused, or signaling those up, taking that shared responsibility of ownership? And then eventually getting to a bit more challenging or more complex things. So using maybe AI and analytics to automate things, or really trend just like we do about our business. Thinking about, do you need a bespoke solution for cost management or cost analysis? And here I think just wanted to wrap up with some places that we're kind of actively seeing people go, or kind of recommendations really. So being just conscious of utilization and determining what those metrics are. So what are the key resources, key cost metrics you want to capture and really get on it, really focus on it. Using DevOps, we've talked about a number of times, a really helpful aid in making the most out of cloud. Education and upskilling. So people both in the IT and the business, so people across the spectrum that are involved in these data and analytics solutions, have them understand cloud economics, infrastructure cost, and be able to apply apply that knowledge to be very thoughtful in decisions. Thinking about migration, so what are some key applications that are hitting resource intensive limits or volume limits? What are big processes in Excel being done on laptops? Identify those and get those in the cloud. You'll really see a big return on those sorts of things. I think championing the modern data platform, so driving data lakes, lakehouse, getting them populated and seeing how that cohesive single repository platform really plays into organizations. So we're out of time here. Thank you very much for joining today. Do feel free to get out with any questions, feedback. My contact details are on screen. Thank you very much and have a great day.